In this lesson, I'm having students compare simple interest to compound interest. In the first table with simple interest is always based off of the principal amount. So it's always based off of that $5,000, that principal amount, the starting amount that we started with, times the interest rate 0.0375 when you change that to a decimal. And you'll always get that that's equal to $187.50. And you can see that's easy for my students to see a linear function when it adds on the same amount, constant rate of change. And when we graph that, that also reinforces that it is a linear function. The second type of interest is more difficult for them to see to compare to that is compound interest. The formula is more difficult for them to use until I actually question them and start reviewing with most of the students. And we talk about that compound interest is not based off of the principal amount, it's based off of the new balance. So you take 5,000 and you multiply times 0.0375. The first year you will get $187.50. But the next year you take the new amount, $5,187.50, and multiply times the interest, which is 0.0375, and you will get a different interest that you're adding on each time, and that's $194.53. And you're always basing that off of the new balance. And then when we graph that, it's difficult for them to see that it's exponential because you can tell it's not linear, it's increasing more rapidly. But it's easier to see when I talk about, well, remember when we compared, what's another way to see what type of function it is, when we look at the pattern and the output values, it's not linear, it's not adding on a constant rate of change. But when you take one of the output values, $5,382.03, and you divide by the previous amount, $5,187.50, well, you get 1.03. And each time you do that, you take an output value and you divide by a previous amount, you get 1.03. And so therefore it is exponential. That's your growth factor of 103%.